Today we're going to talk about three-dimensional plotting, and I first have just a plot command where I'm plotting the y values between 0 and 10 in increments of 1. And so we take a look at this plot and our y values go from 0 to 10. Because we didn't input x values, it'll just start at 1 and keep incrementing by 1 until we get to the end. We can view this data in either three-dimensional or two-dimensional. So here's a three-dimensional view of the data. I can swap back to a two-dimensional view of that data, and I'm back to two-dimensional. I can change my mind again and go back to three-dimensional if I want. So that's the view command, to change the layout from a three-dimensional to a two-dimensional or back. Now, what else can I do with graphing? So let me create some more values for graphing. I'm going to start out with x values between -1 and +1 in increments of 0.5, and that'll give me 5 different values. For my y values, I'm interested in going from 1 to 2 in increments, not in increments of 0.2, in increments of 0.5. So I've got 3 different points. So let me go over that again. My x values, my y values, and imagine I want to graph this, and for every x value, I want these 3 y values, and for every y value, I want these 5 x values. So I've got 3 numbers on the y-axis, 5 numbers on the x-axis. 3 times 5 is 15 points I'm looking for, 15 x's and y's. And I can create that using a meshgrid command. And I'm going to pass in my lowercase x and y values, my 3 y points and my 5 x points, pass those in as arguments to meshgrid, and then it's going to spit out capital X and capital Y, so Matlab's case sensitive, these are different variables. So my 15 points, 15 x points and my 15 y points, and these points should look familiar because my original x values from -1 to 1, I've got that repeated just 3 times. So 3 different rows of the same values. So 1 row for each of the y values. And my y values, I had 1, 1.5, and 2. I've repeated that as a column, and I'm repeating that 5 times because there's 5 different x values. And what happens when I plot my capital X and my capital Y values? And in fact, to make it really show up, I'm going to make them diamond shaped with blue diamonds and plot marker size 20. So this is what I get. I'm plotting those 15 different X and Y combinations, and you can imagine why they might have named this mesh grid, because if you were to connect all these diamonds, you would have 5 different vertical lines and 3 different horizontal lines, and it looks a little bit like chicken wire. It is a mesh grid. And from here, we can use our command to view this as a 3-dimensional plot. And imagine I've got a 3-dimensional view of this data, and for each of these 15 points, I want to add a z value, so a height for this spot in the grid, in the mesh grid. Well, we can do that one of 2 ways, and I set the programs up ahead of time. One way we could do it is to create a surface plot. So I've got the same command I used before in the command window to create my x values, my y values, to get a mesh grid. That's the foundation. And then we're going to add the height, or the z value. For each of those x, y pairs, I'm going to square the x, square the y, and I'll come up with my z value and display it as a surface grid. So we'll run that, and we see a very, very cool looking graph here. All right, what else could we do with that mesh grid? Well, there is just a plain mesh plot for 3-dimensional plotting, and this is only going to require 1 input, and that is just the z values. And here I created my mesh grid, and I used, for the mesh grid, I wanted to create, let me just show you what this one line looks like. Instead of setting up different x and y values ahead of time, I set up, I wanted, let me just type that in again. or we can copy and paste this. Copy. I wanted to set up my grid based on -8 to +8 in increments of 5. So that ends up, we've got quite a lot of points there. I'm going to put them in my X and my Y variables, and we can take a look at, well, X actually has, we wanted to go from -8 to +8, so it's got all of these different values with my increments of 0.5, and the same thing for Y. They're both the same. X and Y are the same. And then I'll create another variable R, which is going to be the square root of X squared plus Y squared plus EPS. If you look at EPS, it is like the smallest possible value that you can represent in Matlab. We can do help on EPS and see what that is exactly. It's the smallest possible spacing between two floating point numbers in Matlab. So we're going to use that and then create our z values, which is the sine of r divided by r. And then I run this and I get a rather awesome looking graphic that often they use this on the front of Matlab textbook covers because it's so cool looking. Okay, so those are two uses of the mesh grid, and I'm going to stop right there.